Okay, today guys, we're going to go over our study guide on proportions. An ice cooler has 10 cans of soda and 15 bottles of water. Write the ratio of cans of soda to bottles of water in 3 different ways. Okay, so let's first take and write the cans of soda using a colon and 15. This is 10 to 15. Let's then use the word to in between the two numbers, and then finally let's write it as a fraction. So each one of these is, you would say 10 to 15 for each one of them. It's really important that you pay attention to the order the information is given. In the second problem, a car on cruise control took 19 hours to travel 1,197 miles. What is the unit rate for miles per hour? Okay, let's take the total amount of miles traveled by the car and divide that by 19, which is the number of hours the car was traveling. When we divide here, you may use your calculator. You should get 63, and make sure you label that miles per hour. In number 3, you want to purchase a box of cereal. You have 3 choices. The first choice, we have a 19-ounce box that costs $3.99. The second choice is a 15-ounce box that costs $3.75. And the third choice is a 21-ounce box that costs $4.50. Okay, let's do the first calculation. We're going to take the total amount of $3.99 and we're going to divide that by 19.5 ounces. You may again use your calculator. Make sure that you do round to the nearest penny. So this first calculation would end up being 20 cents per ounce. The second choice is going to be $3.75 divided by 15 ounces. This calculation should result in 25 cents per ounce. So already when we're comparing these two, it looks like choice 2 is already going to be out because it is more than the first choice. Now let's check the third choice. In the third choice, we have a box of cereal that costs $4.50 and it contains 21 ounces. So with that calculation, you should end up with 21 cents per ounce. So it looks like choice number 1 would be the better buy because it is the least costly per ounce. All right, in number 4, we need to write the ratio in simplest form. So we have 1/4 and we are dividing that by 2/3. Now, if you have your calculator and you have that ABC button, you can go ahead and enter 1/4 and divide it by 2/3. If you do not have your calculator, remember when you divide fractions, you keep the first fraction, change the problem to a multiplication problem, and find the reciprocal of the second fraction. Then you can multiply straight across, and it looks like we end up with 3/8. If you are using a calculator, make sure you're using that ABC button as you enter both fractions. Question number 5. The amount of time Jan spends studying and her test scores have a proportional relationship. So we are to complete the table. Right here, this is some really good information because if they have a proportional relationship, we know down here that these all have to be the same. Since they completed one for us, I know that this fraction is also going to be 16/1, and so is the second one when I'm dividing the test score by the hours studying. This, of course, has to be reduced, and it does reduce to 16/1, as well as the 80/5. So let me put that there too, and you can double check that on your calculator if you wish. In question 6, decide whether the table shows a proportional relationship between x and y. Remember, we always divide the y value by the x value because the y value is the dependent variable. So it looks like this one right here, 9 over 1, since the denominator is 1, it means that the rest of these need to reduce to 9 over 1. So when I write 18 over 2, if I divide both by 2, that definitely does. So far the first two are equivalent. 27 over 3, if I divide both by 3, that also reduces to 9 over 1. And finally 36 over 4, which also reduces to 9 over 1. So this answer would be yes. The table does show a proportional relationship. Okay, question 7. Your friend wants to know if there's a proportional relationship between the number of slices of salami in a sandwich and the number of calories. Decide if the relationship between the number of slices of salami in a sandwich and the number of calories is proportional. So in this one, I can see that if I divide calories, 54, by the number of slices of salami, I get 54 over 1. So that means the rest of them need to be equal to this since my denominator here is 1. When I look at the first one, 63 divided by 2, and I go ahead and try that calculation, that actually does not equal 54 over 1. So I'm immediately going to stop and say no. I'm not even going to do the rest of the calculations, because if the second one does not equal the first, then the rest of them, it really doesn't matter. Okay, let's go on then to the next problem, which is going to be problem number 8. At a cafe, the cook uses a recipe that calls for eggs and milk. The amount of eggs and milk have a proportional relationship. Complete the table. Well, if that is true, then all of these down here need to all be the same, which is 2 over 1. So I immediately know that this right here is going to be a 1. Then I need to figure out the rest of these. So for this one, I need a number that when I divide it by 2, I just get 2 over 1. So this first one, cups of milk, is going to be a 4, because 4 divided by 2 is that 2 over 1. You can think about it, instead of dividing, multiplying these two together and getting that 4. In the next one, I need a number that if I divide it by 6, I end up with 2 over 1. That missing number happens to be a 3. If you want to test that, cups of milk over the number of eggs does reduce by dividing both by 2 to that 3 over 1. Okay, let's move on then to the very next problem, which is going to be problem number 9. Which of the following graphs shows a proportional relationship? Well, the line must be straight and it must go through the origin, so it's got to be this one right here. This does not pass through the origin, and this line is not straight. Moving on to question 10, the graph shows a proportional relationship between time and the number of boxes a machine packages. How many boxes does the machine package in 6 minutes? I can see that minutes is here on the x-axis. If I follow up the 6 minutes to where the line is, then I'm going to follow the line over, and it looks like it's 210 boxes. Moving on to the next question, question number 11. The graph shows the relationship between the distance a taxi travels and the cost of the taxi ride. Is the relationship proportional? And explain. Use pencil and paper. What is true about ratios for proportional relationships that is not true about ratios for other relationships? As you can see from this graph, that line is straight, so that's what's true about this, but it doesn't pass through the origin. So this is no, there is not a proportional relationship, and that is because the line does not pass through the origin. You can also say 0, 0 if you would like to. Okay, moving on to question 12. Name the coordinates of the points. So we have 3 points here. If I do the first one, letter M, make sure you always start at 0. We would move left to find the x coordinate, that is 6. And since it's right on the x-axis, that means the y value must be 0. So there's the first coordinate. It is negative 6, 0. For letter N, again, start at the origin. You have to move left first. The x-coordinate is going to be negative 3. Then if you go up to 2, that y-coordinate is positive 2. For letter P, again, start at the origin. We do have to move right this time to 3, so our x-coordinate is positive 3, and then we move down, and it looks like the y-coordinate is negative 2. So when you are naming coordinates or graphing, the first thing you want to do is find the x value. So you will always either move from the origin either left or right. The second movement is to find the y value, and you will either move up or down. For number 13, we're going to graph a point. So the first number 7 is the x value, the second is the y value. So here we go, we're going to start at the origin. Positive 7 is located to the right, so there it is. And then we're going to move down to negative 4. So that coordinate would be right there. Positive 7, negative 4. Question number 14, does the equation y equals 2x plus 1 show a proportional relationship between x and y, and then explain? Well, the quickest way to do this problem would be to create an xy chart and go ahead and fill in values for x. So let's say we use 0, 1, and 2. If I put a 0 in here, 2 times 0 is 0, plus 1 is 1. If I put a 1 in there, 2 times 1 is 2, plus 1 is 3. And finally, if I put a positive 2 in there, 2 times 2 is 4, plus 1 is 5. You can see that these coordinates do not result in passing through the origin, so this would be a no. So I can disregard the yes answers here. My no is going to be because the equation does not pass through the origin. You can see from my coordinates there that when x is 0, y is going to be 1, so choice D is the best answer. In question 15, to solve the proportion, this is what we most recently learned, and you're going to use cross product property. So I'm going to move cross here diagonally and multiply. 2 times x is 2x. Keep the equal sign, and then move this direction. 4 times 8 is 32. Now I'm going to undo this multiplication, 2 times x. The opposite would be to divide by 2. To get x, my missing value, 32 divided by 2 is 16. And that's it. Thanks for watching.